Welcome back to my YouTube channel Sriram Devarajan. In this video I am going to solve Madras University question paper. This is the latest question paper November 2025. This is part of previous year question paper series for the subject Applied O.R for MBA students Madras University. I am going to discuss one problem in this video. The problem was asked in part B for 5 mark. Problem is 14 to 1. We have to find the solution for this LPP linear programming problem by using graphical method. Problem is given as minimize z equal to 20x1 plus 40x2 subject to 3 constraints. First constraint 36x1 plus 6x2 greater than or equal to 108, 3x1 plus 2x2 greater than or equal to 36, 20x1 plus 10x2 greater than or equal to 100, where x1 comma x2 greater than or equal to 0. If you study LPP, that is linear programming problem, this minimize z, we call it as objective function. These three inequality, we call it as constraints equation. This one non-negative constraints. What is given? Problem given as minimize z equal to 20x1 plus 40x2. This one objective function subject to 3 constraint equation. First constraint 36x1 plus 6x2 greater than or equal to 108, 3x1 plus 2x2 greater than or equal to 36, 20x1 plus 10x2 greater than or equal to 100. First of all, you notice that in a minimization problem, all the inequality should be greater than or equal to. The last one, x1 comma x2 greater than or equal to 0. This is non-negative constraint. Total constraint equation 3. I am going to solve this LPP with the help of graphical method. What is the first constraint equation? In a graphical method, first of all, convert the equality. This inequality will be changed into equality if we use graphical. Therefore, constraints equation now becomes 36x1 plus 6x2 equal to 108. Divide by 6. 6x1 plus x2 18. Equation 1. Similarly, what about the second constraint? 3x1 plus 12x2 greater than or equal to 36. 3x1 12x2 greater than or equal to 36. Once again, convert inequality to equality. Therefore, now constraints, second constraint 3x1 plus 12x2 becomes equal to 36. Divide by 3. x1 plus 4x2 equal to 12. Equation 2. What about the third constraints? 20x1 plus 10x2 greater than or equal to 100. Again, convert this into equality. It becomes 20x1 plus 10x2 equal to 100. Divide by 10. 2x1 plus x2 equal to 10. This is equation 3. solution for this LPP with help of graphical method. First constraint, convert inequality into equality. It becomes 36x1 plus 6x2 equal to 108. Divide by 6. 6x1 plus x2 equal to 18. Equation 1. Second constraint, 3x1 plus 12x2 greater than or equal to 36. Again convert into equality. 3x1 plus 12x2 equal to 36. Divide by 3. x1 plus 4x2 12. Third constraint, 20x1 plus 10x2 greater than or equal to 100. Again convert inequality into equality. 20x1 plus 10x2 equal to 100. Divide by 10. 2x1 plus x2 equal to 10. This is third equation. This is step 1. Now step 2, to find the point for all the three equations. Initially the problem is given in the form of a constraint. By using graphical, converting inequality into equality, now all the constraints equation becomes equation. First equation, 6x1 plus x2 18. Second equation, x1 plus 4x2 12. Third equation, 2x1 plus x2 equal to 10. How to find? Finding the point for x1, put x1 equal to 0, 0 plus x2 equal to 18. Therefore x2 equal to 18. Points are 0, 18. Now put x2 equal to 0, 6x1 plus 0 equal to 18. 6x1 equal to 18. x1 equal to 18 by 6. Answer is 3. For the equation 1, the second points are 3, 0. For equation 2, x1 plus 4x2 equal to 12. Putting x1 equal to 0, 4x2 equal to 12, x2 equal to 3. Points are 0, 3. Now put x2 equal to 0, x1 plus 0 equal to 12, x1 equal to 12. Points are 0, 3 and 12, 0. For equation 3, 2x1 plus x2 equal to 10. If I put x1 equal to 0, x2 equal to 10, points are 0, 10. Now put x2 equal to 0, 2x1 equal to 10, x1 equal to 5, points are 5, 0. For equation 3, points are 0, 10 and 5, 0. With the help of this point, draw the graph. This is step 3. First point 0, 18, second one 3, 0, third one 0, 3, fourth one 12, 0. Fifth one 0, 10. The last point 5, 0. Now with the help of a graphical method, I am going to find the solution for the problem. The points are 0, 18, 3, 0, 0, 3, 12, 0, 0, 10, 5, 0. 0, 18, you mark it as A in the graph. 3, 0, mark it as B, joining these 2 points by a straight line. Similarly for CD, 0, 3 and 12, 0. This is the point 0, 3. This is the point 12, 0. Again join these 2 points by a straight line. 0, 10 and 5, 0. This is the point E, 0, 10. This is the point F, 5, 0. Again join these 2 points by a straight line. Because of problem minimization, I am shading above the lines. This is the region, shaded region. This one is our feasible region for this problem. Therefore, the feasible region near to the point are A. We have to find these 2 intersecting points, and the nearest to the region, the points are D. A, you mark it this point as G, this point as H, A, G, H, D. This is our feasible region. We know the points for A, We know the points for D, but we have to find the points for G and H. For G, the lines intersecting are AB, first constraint equation, and EF, third constraint. For H, the two lines intersecting are EF means third equation, CD means second equation. For G, solve the first equation and third equation. For H, solve third and second equation. Again, see the intersecting point. These two lines are intersecting. These two means AB, EF, 1 and 3. For H, these two are intersecting. These two means EF and CD. EF and CD means third equation and second equation. Now, from the graph, feasible region is A, G, H, D. To find G, this is A, this is B, C, D, E, F. Points are for A is 0, 18. Points for B 12, 0. We have to find points for G. For G, first and we have to solve equation 1 and 3. What is the equation 1? Six x1 plus x2 equal to 18. What is third equation? 2x1 plus x2 equal to 10. If I solve by elimination method, if you subtract these two equations, plus x2 minus x2 cancel, 4x1 equal to 8, x1 equal to 8 by 4, 2. Substitute x1 equal to 2 in 6x1 plus x2 equal to 18. 6 into 2 plus x2 equal to 18. x2 equal to 18 minus 12, 6. Therefore, G is 2, 6. Now, to find H. For H, solve second and third equation. What about second equation? x1 plus 4x2 equal to 12. What about third? 2x1 plus x2 equal to 10. Solve by using elimination or substitution method. Here x1, here 2x1. If I make use of elimination, multiply first equation by 2x1, that is 2, 4 into 2, 8x2, 2 into 12, 24. Multiply by 2. Now subtract. plus 2x1 minus 2x1 cancel, x2 minus 8x2 minus 7x2, 10 minus 24 minus 14, x2 is 14 by 7, that is 2. x2 to substitute in x1 plus 4x2 equal to 12. What is x2? 2. x1 plus 4 into 2 equal to 12. x1 equal to 12 minus 8. x1 is 4. x2 is 2. Therefore, h point is 4, 2. Step 4. The corners are AGHD. How I am choosing the points AGHD? These 4 points nearest to the shaded region, nearest to the feasible region. A point 0,18, G point just now we find out 2,6, H point 4,2, D point already we find the value for D. Value for D is 12,0. At A, what about Z value? At G, what about Z value? At H, what about Z value? At D, what about Z value? Actually, what is Z? The problem is minimization. That is objective function. Z is 20x1 plus 40x2. x1 plus 40x2 is Z. At A 0,18, x1 0, x2 18, 0 plus 40 into 18, 720. At G 2,6, 20 into 2 plus 40 into 6, 40 plus 240, value is 280. At H 4, 2, 20 into 4 plus 40 into 2, 80 plus 80, 160. At D 12, 0, x1 12, x2 0, 20 into 12 plus 40 into 0, 240 plus 0, 240. At D, Z value is 240. At H, Z value is 160. At G, Z value is 280. At A, Z value is 720. Since the problem is minimization problem, choose the minimum value. Here 720, 280, 160, 240. Minimum value is at H 4, 2, Z value is 160. Therefore, minimum value is Z equal to 160. At H, x1 is 4, x2 is 2. Therefore, the answer for the problem with the help of graphical method, answer is 160, x1 is 4 and x2 is 2. I have solved one LPP problem with the help of graphical. I got the solution for the problem. Z is 160, x1 is 4 and x2 is 2. I will solve remaining problem from the same question paper. For MBA students, Madras University question paper, I have solved one problem from November 2025 latest question paper. I will upload remaining problem from the same question paper in the upcoming video. If you like this video, share it with your friend, subscribe it for more video. Thank you for watching. Happy learning.